I made a shirt. So, I made a t-shirt for YSP, which is a Young Scholars Program. It's a program at the University of Chicago where we learn about math that isn't typically taught in schools. So, yep, today I got this t-shirt finally, which I was hoping will get printed, the design will get printed on. I created the design for the t-shirt, which has a piecewise linear function and a interval map. So, I'll give my best shot at explaining what these are, what it means, and stuff like that. So, this shirt is a Markov system, or you can call it a Markov circuit. And basically, it is taking a bunch of different points, which have some certain value, and then, in probability terms, it's trying to see what the chances are of something connecting to something else, I suppose. Or what are the chances of, for example, this 11 points to go to this 2 point, which is 100% because it can only go to the 2. Or I guess a better example, what are the chances of this 6 going to the 4, going to the 5, or going to the 7? So although probability is the basis of what Markov circuits are, we kind of decided to just design something that could follow the same general rules of a Markov system and trying to go all out and making a YSP shirt. So we begun by using this piecewise linear function. Now this is also a Markov system, but it's in the graph terms. So basically what's happening here is that the values on the x-axis map to the values on the y-axis. So I guess a good explanation is the reason why this is 0 and 1, that represents 0% and 100%. So those are the probabilities of something happening. So a good way of saying this is just using examples. So you can say that 1 on the x-axis will go up here and then map to the 10. So that means that in this Markov system, the value of x will go to the value of 10. And this process continues for all of these different values on the shirt. So if we come over to the shirt, you can see that that the 1 goes to the 10. Yeah. So 1 will have one arrow point out, go to the 10. And then I guess now they're at 10. Let's say, okay, since we started it with 10 here on the, we went from 1 to 10. Now let's move to 10 here and see what the next probabilities are. Well, 10 can go to this section or this section, which is 1 or 3. Alright, so the 10 has 2 arrows poking out. It can go back to the 1, or it can move down to the 3. So that's what a Markov circuit is. It's kind of just leading down these sorts of paths of probabilities and just seeing, oh, what are the chances I'm going to follow down this path? So you can move down all around these paths, move around the Y and the P, and then you can also move around the S as well. So, maybe you're wondering, okay, so why are the Y and the P all in this big line across each other, and then the S is just on its own? Well, this is because it's broken up in the pattern is broken up into 2 circuits. So, not circuits, 2, oh gosh, what was it called? 2 orbits. No, not orbits. Alright, I found out. There's 2 connected systems. So, basically, the one connected system is this P and this Y section, and then the other connected system is just this S. So, if we're looking on the graph, imagine these as like in their own boxes. So this Y is within this kind of box here from 8 to 11. The S is in its own box from 4 to 7, and then this P is in its own box from 0 to 3. So what happens is, whenever you choose anything that's touching the Y, it's always going to correspond to one of these top points, which will always go back to the P. So basically, the y will always go to the p, and the p will always go to the y. But if you stick within the s from the 4 to 7, it'll always only map to a 4 or a 7. So the s stays within itself. So actually, that means that the s on this graph is actually the same as this s on the shirt. While the y and the p values, they're mixed up. Like the 1 is here, the 8 is over here, 10 is over here, 3 is over here. It's all over the place. Actually, the reason we did that is because we wanted to show off the number 2018 on the top. On every YSP shirt, you gotta have the letters YSP, but you also need the year number. So, one of my friends actually gave me the great idea of putting the values 2, 1, 0, and 8 on the top to make it read out 2018. So, the values of the Y and the P are mixed up, but the S central on its own. It's pretty cool. Yep. Right, so Markov systems and Markov circuits are usually related to more, their probability aspect is more related to things like artificial intelligence and machine learning. So what the probability means is that when the computer gathers enough data, it can try to guess, okay, I think the chances of it turning into this next, or the chances of it turning into that next, can be applied, which is exactly what Markov systems are. So I think the best example of this is in text. So, for example, in an individual word, the best way to represent pronounceable words is by going through this list of existing English words and trying to see the patterns between it. So, for example, whenever there's a Q in the English language, you always know it's going to be followed by a U. Like, there's no other combination. It's always QU. So the probability of the Q going to U is 100%. But meanwhile, if you have the letter U, this can usually connect to lots of other things like vowels, A, I, stuff like that. So the percentage is more split up. But based on what the computer is fed, it will give these each a value based on how much it's seen that happen. And then on its own, it can generate new words based on these probabilities, just kind of rolling the dice and saying, okay, I'll choose that next to create it, just using Markov systems. And this can be applied to more interesting things like the randomized level design of roguelike video games, or even predicting the weather, looking at previous weather examples, previous weather conditions, and what has been following it, what has been in the past, and connecting those to predict what's going to happen after today, stuff like that. And that's at the basis of what machine learning and artificial intelligence are. So that's pretty cool.